Hello student, in this lecture we will study the properties of nth root of unity. In the previous lecture we studied that nth root of unity like 1, omega 2 dot dot omega n minus 1, these are the roots of omega to the power n is equals to 1, and in they are geometrically represented as the lies on the circle with equal angles spaced. Like if this is the omega 1, this is the 1, this is the omega 2, then the angle between these two corresponding radius to the point, the roots of the this equation will be 2 pi by n. Okay, so in this lecture we will study that if this point satisfy this geometrical aspect, then what is the properties of this point. Okay, so first properties of is this, that since the angle between these two radius corresponding to point are equal, so the distance between these 2 points, okay, like there is the mod of 1 minus omega 1 is equals to mod of omega 1 minus omega 2, so dot 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 omega n minus 2 minus omega n minus 1. So these distance are equal because the corresponding angle between these two radius is equal. Okay, and this from the according to the properties of triangle. Okay, and second properties is that they are in GP with common ratio r is equals to e to the power I 2 pi by n, and which is very clear. If you take any ratio, any point, okay, omega k is equals to e to the power I 2 pi k by n, and the previous one is the omega k minus 1 is equals to e to the power I 2 pi by k minus 1 by n, then omega k by omega k minus 1 is nothing but e to the power I 2 pi by n. Okay, so this is the second property. And what is the third property? Third property is that sum of this root, like 1 omega plus 1 plus omega plus 2 dot 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 omega plus n minus 1, this is equals to 0. Okay, and how we can prove that? So proof is very simple. So the equation, the polynomial equation is nothing but omega to the power n is equals to 1. So we can take 1 here, so omega to the power n minus 1 is equals to 0. So a polynomial, okay, a polynomial equation with degree n can be written in the form of like an x to the power n plus an minus 1 x to the power n minus 1 dot 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 a naught. Okay, so here also x, here w and n is equals to 1. So, and there should be some like omega to the power n minus 1 term, but there is no such term. And okay, actually here n minus 1, okay, actually the term, here if this is the polynomial equation like is equals to 0, then sum of roots is equals to minus a n minus 1 by a n. Okay, and here there is no such omega to the power, no such omega to the power minus n terms. Okay, so this term 0, so sum of roots is equals to 0. Okay, this is the very clear, and this is the very important concept. Okay, the three are very important concept, and you will see I will proceed further and you will discover some other important properties. Okay, so again fourth property is that, so just I don't write the property first, just prove Just first see the proof of this property. The proof is that some statement or some calculation I am written down. Just see it. The equation is omega to the power n is equals to 1. Okay, so omega to the power n minus 1 is equals to 0. Okay, and omega to the power n minus 1, and we have its root are 1 omega 2 dot 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 omega n minus 1. So these can be factored. Okay, you know, these can be factored into omega minus 1 omega minus omega 1 dot 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 omega minus omega n minus 1. Okay, and this is equals to omega to the power n minus 1. Okay, so what is the divide by both side by omega minus 1? So omega minus omega 1 omega minus omega 2 dot 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 omega minus omega n minus 1 is nothing but omega to the power n minus 1 by omega minus 1. And this is also nothing but in your algebra class you know that it is nothing but omega to the power n minus 1 plus omega to the power n minus 2 dot 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 omega to the power n minus n, and that is equals to 1. Okay, up to 1, and that means they are in terms. Okay, so put n is equals to, not n, omega is equals to 1. If we put omega is equals to 1, then we get 1 minus omega 1 1 minus omega 2 dot 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 1 minus omega n minus 1, and that is equals to 1 plus dot 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 in terms or in times, and that is equals to n. So these we get a very important properties like 1 minus omega 1. Okay, the property is 1 minus omega 2. Here it is 1 minus omega 2 dot 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 1 minus omega n minus 1 is equals to n. This is a very important property. Okay, and another property is, and this one is 4, so this is the 5. Okay, we have the identity like omega minus omega 1 omega minus omega 2 dot 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 omega minus omega n minus 1 is equals to omega n minus 1 plus omega n minus 2 dot 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 1. So now put omega is equals to minus 1. Okay, so it will be minus 1 minus omega 1 minus 1 minus omega 2 dot 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 minus 1 minus omega n minus 1 is equals to minus 1 to the power n minus 1 plus minus 1 to the power n minus 2 dot 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 1. Okay, and if you simplify it and if you consider this, then if n is okay, and up to this we get okay some like 1 plus omega 1 this type of term 1 plus omega 1 1 plus omega 2 dot 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 1 plus omega n minus 1, and this will be 0 if n is even. Okay, and it will be 1 if n is odd. These are very important. This identity will be 0 if n is even, if 1 then it will be 1 if n is odd. Okay, so sixth property is, what is the product of the root like 1 into omega 1 into omega 2 dot 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 omega n minus 1. So you know what is the omega 1, that is the e to the power I 2 pi by n into e to the power I 2 pi into 2n, so into e to the power 2 pi by n minus 1. Okay, and if you simplify it, you will get e to the power I 2 pi by n into n minus 1 by 2, and that is equals to 2 to cancel out, it is the n cancel out, so it is nothing but e to the power I pi into n minus 1. So this is nothing but cos pi n minus 1 plus I sin n minus 1, that is equal to 0. Okay, and this will be 1 if n is odd, and it will be -1 if n is even. Okay, so these are 6 property, and this 7 property, this just I write down this property. You can easily verify this property. Okay, that is the 1 to the power p plus omega 1 to the power p plus dot 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 omega n minus 1 to the power p is equals to, this will be 0 if p is not an integral multiple of n, and it will be n if p is an integral multiple of n. Okay, so we now discussed, we have discussed the 7 important properties of innate root of unity. Okay, so today's lecture is up to that, and further lectures and some problem we'll discuss in the after lecture. Okay, in the third lecture. Okay, thank you.